Today, geometry, we are going over PO63 today, which are properties of angles inside, outside, or on the circle. All the different combinations of angles that aren't central or aren't inscribed, right? We talked about those central and inscribed angle relationships. Here's every other possible combination that you could have. We're going to draw a picture. I'm going to give you a formula. And then you're going to use that on the next page, which you can see if you haven't flipped the page already. There's a whole bunch of diagrams, and it shows all the different combinations of what angles could look like within a circle. If you want the number game one more time this year, you will all need to do both today's and tomorrow's homework. I need to still find that second coin. The sheets that I have, I don't know. I'll go back and I will listen to every recording that we've done this year to try and find.
I remember one year this morning. You put it on. You had the same number on the board, but I guess that number.
I love how great some of your memories seem to be when you constantly say, "I forgot my computer," right? It's like it's interesting to remember that, but not.
Because we care about where no, we care about whether we get done.
Okay. The first type. An angle with a vertex at a point of tangency, and this is theorem 1011. What this is going to look like is basically, you'll have a point on the circle with a tangent line, ray, segment, or whatever going out, and then a secant ray, line, segment going up. Okay? And what that creates here, it creates two angles, angle 1 and angle 2. It also creates a couple arcs. We'll call this point P. We'll call this point A, and we will need a third point on the outside of the circle here, point B. Okay. And when you've got a tangent and a secant, so if you want to kind of try and name these, like what's going on here, this would be the tangent secant combination, okay? And what happens here is angle 1 is equal to half the measure of arc AP. So let me then parentheses do I if it's all in this. Half the measure of arc AP. And the measure of angle 2 is going to be half the measure of arc ABP. Right? So the tangent secant combo, it's kind of like inscribed angles. You know, you have that relation. We just got done talking about inscribed angles, the angle being half the measure of the arc. That's essentially more or less what we have here. Okay? So angle 1, the smaller angle, half of the minor arc. Angle 2, the larger angle, half of the major arc. And Audrey, questions? Then shoosh. All right. Good? Fine. All right, that one's too easy. We'll go on to a more challenging one now. Angles that intersect inside a circle. This is the chord combo.
Chord.
Yeah, this is what happens when you get an angle that is created by two chords intersecting. So we got circle, and let's put a chord here and a chord there. All right.
Look at that circle.
And we'll label our points A, B, C, and D. We'll label this angle here angle 1. Okay. And what's going on here, angle 1 is equal to 1/2 the sum of the arcs created by angle 1 and its vertical. So AB is the associated arc with angle 1. The angle vertical with angle 1 is over here, and the arc associated with that is CD. Okay? So half the measure of arc AB plus arc CD is the measure of angle 1. I'm going to put these arcs in red as well so that we can see that that's what I'm talking about there. So angle 1 and its vertical, half the sum of those associated arcs. If we draw an angle 2 here, it's a similar thing, right? The arcs that angle 2 and its vertical create are AC and BD, and the formula is the same. Angle 2 is going to be half the sum of arc AC plus arc BD. That's the chord combo. How we doing? Similar questions? Fine. The third combo actually has 3 parts to it. Angles that intersect outside the circle. But the good news is the formula is the same for all 3 situations. Okay? You can either have, boys, what's so funny? What?
You should stop.
Who?
Me.
Do you need to go get a drink of water?
I'm fine.
All right. Okay. You can either have a tangent and a tangent. You can have a tangent and a secant. Okay. Or you can have, ooh, that one's very good, a secant and a secant. All right. Those are the 3 options for an angle that starts outside the circle. There are no chords involved here because chords are all inside the circle. So for angles that are outside the circle, you have either tangent, 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 secant, or secant, secant. All right. And in every situation here, the types of angles that you get, you'll get a big angle and you'll get a small angle, right? In the first one, our big angle is the major arc going around there. Our small angle is the minor arc that's kind of on the inside there. In the second example, our big angle, or big arc, I should say. Ooh, why is it in black? Our big arc is on the outside there. Our small arc is the inside one. And in the third example, our big arc is on the outside here. And our little one is right there on the inside there. Right? So in each situation, regardless of what you have, if the angle starts outside the circle, you end up with a big arc and a small arc. Everyone see that? Okay? And the formula for all of them, the measure of angle 1, which angle 1 we'll put in here, okay? The measure of angle 1 is equal to 1/2 the difference of the big minus the small. Okay? 1/2 the difference of the big arc minus the small arc. So if you look back at the top of the page and kind of work our way down, the first theorem is just half of the arc. Okay? For chord, it's half the sum. For the angle outside the circle, combination of the tangents, secants, and whatever, it's half the difference, big minus small. All right? Questions on any of that? It's all just too easy?
No.
Okay. All right, let's look at some practice here. Okay. All right. Says solve for each value. If possible, write which theorems you are using. So as we talked about with inscribed angles and the chord theorems that we talked about earlier, take a look at what you have, right? In this first diagram here, what do you have? Where is your angle? Is your angle on the circle, inside the circle, or outside the circle? Okay. Our angle, its vertex, is on the circle, which is the first theorem that we talked about. Okay. The vertex of this angle being on the circle, we've got that tangent secant, or tangent chord in this case, relationship here. And so angle 1, we've got this arc coming around here. Our formula for that was the measure of angle 1 was half the arc, right? Our arc measure is 260. So angle 1 is going to equal half of 260. And so angle 1 is going to equal 130. No? If you start and say, okay, what do I have? Where's my vertex? What am I working with here? Get the picture, get the formula, and just plug the values in. Right? The next one asks for arc AB. Arc AB is this distance here. Again, take a look at the picture. Where is your vertex? On the circle, inside the circle, outside the circle. It's on the circle, meaning it's that first theorem that we talked about there. And if the angle is half the measure of the arc, right? Measure of angle 1 is half the measure of the arc. In this case, it does give us letters, arc AB here. And we're given the angle, that means that 65 is half the measure of arc AB. And if we're asked to find the measure of arc AB, what would arc AB be? That 65 would be half of it. 130. If I'm going too fast, stop me, please. Well, y'all said the first page was easy, so here we go. Y'all said that.
In fact, we stayed silent.
Yeah, we.
Yeah, sure, you did say that. The next one, take a look at where your vertex is. On the circle, inside the circle, outside the circle. Our vertex is inside the circle. So we know that we are working with that chord combo. And so you look back at the formula for the chord, and it says that angle 1 is equal to 1/2 the sum of the associated arcs. So in this case, that position of angle X there, the associated arcs are the arc that it creates, which is arc CD, and the arc its vertical angle creates, which is arc BA. And so plugging in those arcs into our formula, it's half the sum of arc CD plus arc BA. And now in this case, the angle is what we're trying to find here. So X is equal to, kind of plug in values here. Arc CD is 145. Arc BA is 85. (145 plus 85 is 230. And so we know that the measure of that angle X, is going to be half of 230. Please don't stay silent. How are we doing?
I don't like the. I mean, I like your sex.
I'd certainly be a
last
lot
five
better with $50.
Would you?
Certain, I'm just saying.
Same.
I don't have a job,
I'd be better with.
and you're at your job every month, so you
True.
should have some money.
Yes.
I'd be
Maybe
better
not
with like
$50.
I put everything I have in lit coins, so my future is tied to that.
I'll take it all.
Unfortunately, it has dipped severely in the last month or so. So things are a little bit tight. We're eating off the dollar menu. Okay. Okay. Pick one that looks a little bit more intriguing. Then, you know, it's part of it is getting the relationships. You know, and then like so don't do the last one yet. We'll save the last one.
Second to last one.
But getting those relationships and then the algebra behind it might be the most challenging. Bubbles, what do you want to do?
Second to last one.
Second to last one. All right.
Nice one.
So, step one here. What is the situation? Where is the vertex? On the circle, inside the circle, outside the circle. Our vertex is outside the circle, which means we're dealing with one of the bottom three formulas, right? You can match this picture up with what we drew on the first page, right? That very last one, the secant combo. In the secant combo, and in fact, any situation where the vertex is outside the circle, we're looking at the big angle minus the small one, right? So our big angle is UV. It'll always be that outside, the further angle, right? Because as this angle expands out, the second, I'm not just picking it the big angle because it looks like it mathematically. As it expands out, it's going to get bigger, right? And then our small angle is going to be the inside angle of that x plus 6. So once you identify those pieces, you know, here's big, here's small, plug them in, right? Our formula says that the measure of the angle, which is given to, I'm not going to plug in values yet here. Our formula says that the measure of the angle is equal to 1/2 the difference of the big minus the small. Angle 1 is given to us. It's 34 degrees. So 34 is 1/2 the difference. Our big angle is 3x minus 2. Our small angle is x plus 6. And here's where folks oftentimes make mistakes. Because x plus 6 is just more than one term, and we're subtracting the entirety of the small angle, what do we need to do here? We need to put that small angle in parentheses, right? Because if I just write minus x plus 6, I'm really only subtracting x and then adding 6 to that total. What I want to do is subtract x plus 6, the whole thing. Okay? The whole thing. I don't need parentheses around my first angle, however, right? It's that subtract. If I was adding here, I wouldn't need parentheses around that second thing. It's the fact you're subtracting that whole quantity, and the properties of subtraction are why we need parentheses there. So we can distribute that negative sign into our parentheses. -1 times x, negative x, and -1 times 6 is a positive 6. So that's the only thing. Watch out for that. If you're subtracting an expression, that expression needs to go in parentheses. And by expression, I'm talking about something with more than one term. Okay. Now we can combine like terms within our parentheses. 34 equals 1/2 of what? What does that whole thing come out to be? Not 4x minus 8.
Oh, 2x minus 8.
2x minus 8, right? 3x and a negative x is a 2x. -2 minus 6 is a -8. And I got some like terms here. 3x, negative x, -2, -6. What are my options now? What are my options now? Back to algebra. What are my options? Adam. So one way to get rid of this half out in front and unlock those parentheses would be to divide both sides by 1/2, which is the same as multiplying both sides by 2. So that's an option, right? If I did that, if I divided both sides by 1/2, or again, doubled both sides, I will get 68 equals 2x minus 8. Nice two-step equation to solve there. What's my other option? If I didn't want to divide by a half, what else could I do? Yes, say it. Distribute the half, right? If I do that, then my 34 doesn't change because I didn't move anything over, but my expression in parentheses becomes x minus 4. Half of 2x is x, half of negative 8 is a negative 4. I get 38 for both answers here. Okay, so x would equal 38. Whether you move the 1/2 over or distribute, x equals 38. Which isn't my answer though, right? Because my answer, or what I'm trying to find, is arc TW, which now that I know that x is 38, is simply 38 plus 6. Just plug the value for x in there. And then arc UV, which is 3x minus 2, is 3 times 38 minus 2. So this is another one of those tests where just solving for x isn't good enough. You have to then apply that value to the expression. Okay? You think you can handle this?
No.
No? Okay. There's what? There are a lot of numbers. Yes. Well, luckily you don't have to solve for angles 1, 2, and 3 here, so you don't got to worry about 4. I can help you get set up on another one. Nathan? For right here, yes. I did it 2 different ways. One way I distributed the half, so half of 2x is x, half of negative 8 is negative 4. Adam also said you could divide both sides by 1/2, since that's a coefficient of the parentheses, which dividing something by 1/2 is the same thing as multiplying by 2. So that gave me 68 on the left, and then this just cancels out, so I've got 2x minus 8 on the right.
And then you add,
so then I'd add 8 divided by 2 here, and then on the other one I'd just add 4. Well,
we did the middle one.
the middle one, I was hoping you wouldn't say that word.
Why?
Because this is the one. Okay, let's just set it up here. Right? So what do we know? This particular situation, we have our vertex inside the circle, which means that chord-chord combo, right? And the formula for the chord-chord combo is angle 1 is equal to 1/2 the sum of the associated arcs. Okay, so I don't know how to write that, just arc plus arc, but in this case, with this particular situation, we have angle x there, right? And according to the formula, that's going to be equal to half the sum of the arc of angle x, and it's vertical. So that's arc ML here, right? That's associated with angle x, and arc JK. But what's the problem here?
That's an L?
This? It's supposed to be, yes.
It looks like a C.
Sorry. That looks more like an L there. What's the problem here, though? If I start to plug in values into our equation, we don't know what ML or JK is, right? We don't have values for those. We are given values for the other 2 angles, okay? And so what would the measure of this angle be here? Because we do have, I'll do that differently. We do have arc measures for this angle, right? KL and JM, but we don't have a value for that angle. So what do we write? Peter? Well, let's try this here, right? If this angle here, I'll kind of draw the situation with these 2 chords intersecting here. If this is angle x, what could we put for the measure of that angle there? Bubbles. If they were perpendicular, yes. We don't know that.
It is.
We don't know that.
It looks like it.
It looks like it is. Let's take it.
Yeah, just drawing a
like it.
Looks like. What could we write? What expression would represent the measure of that red angle there that we would need to use these two arcs in our formula? Yes. That's what the measure of the angle would be, right?
Yeah.
Just call it angle 1. You know? Angle 1 is equal to 1/2 the sum of 2x minus 30 and 30. Now what happens with our negative 30 and our positive 30? They cancel out. Which means that angle 1 equals half of 2x. What's half of 2x? X. And if angle 1 equals x, if angle 1 equals x, and that angle equals x, what's the value of x?
You didn't listen to me.
It's 90 degrees. That's why I don't like to do that one, because it looks like it, people end up being right. I wish it was like 89 and 91 degrees or something like that. Just off enough where it still looks like it, but not quite. But the point of this is that,
like it.
you know, we have variables for a reason, right? We have unknowns for a reason. If we want to find something, we don't know what it is, assign it a variable. It's angle 1, right? And then go from there. That was the point of that one. Okay.
Looks like it.
Play with this, see what you can do. We'll go over it tomorrow. Earn the number game tomorrow, please. Do your homework. It's just the rest of this page. Give it your best go. Look at the diagram. Look at what you have. Look at the formula and go from there. That's how you math, folks.
Don't forget to like and subscribe.
Thank you, Blake.